We're going to solve some equations that involve logarithms and exponential functions. And in number one, we're going to try to solve this equation here. What is the value of x? 5 raised to what power is 625? Well, we might be able to guess this one because it's nice numbers, but you know that 5 to the first is 5, 5 squared is 25, 5 to the third is, how about if I write 5 times 25, which is 625. So we could guess this one to be 3. But let's not do it by guessing. If this was a 626 instead of 625, I don't think we could do this. So let's use logarithms. So let's start here. 5 to the x equals 625. And I'm going to use logarithms because I have an exponential function. So it's exponential because the variable is in the exponent. So if I have an exponential function, I will undo the exponential function by taking logarithms. So let's take the logarithm of each side. Now I want to use my calculator on this. So I could use log base 10, the common log, or log base e, the natural log. Why not just use the natural log? So I'm going to take the natural log, if I can write it correctly here, the natural log of 5 to the x is equal to the natural log of 625. Now, by the properties of logarithms, right, we can bring this down in front as a multiplier, so I'll get x natural log of 5 equals the natural log of 625. Now, I'm trying to solve for x, so why don't we just divide by this? So we'll get x is equal to this quotient here, natural log of 625 divided by the natural log of 5, and just put this in your calculator all at once. So here's what I'm going to do. I'm going to press, now I have to press the second key, and then I'll press the log key, because right above the log key is the natural log. So you press that, then you get a set of parentheses, type in 625, close the parentheses, press divide, and then second again, and then the log key again, and right above it's natural log, so you get a parentheses and type in a 5 and close it. And sure enough, this comes out to be 4. Oh, which is a good thing I did that, because what did I do up here? I said it was 3, thinking that 5 cubed was 625, but it's not. It's only 125. And then 5 to the fourth is 5 times 125, which is 625. Oh, well, good. Glad I checked that. All right, so this is the way we want to do those anyway, with logarithms instead of guessing, because, at least for me, guessing doesn't always work. And here in number 2, I got 5 to the x is 17, which I don't think I can guess this one at all. I know 5 to the first is 5, 5 squared is 25, right? So here's what I do know. 5 to the first is 5. I'm going to leave it blank. 5 squared is 25. We're here at 17, so this must be 5 to some number between 1 and 2. Let's use logarithms to see what it is. So take the log of each side, and I'll take the natural log. Or you know what? We took the natural log last time. Let's just take the regular log this time. Common log. The log base 10 of 5 to the x is equal to the log base 10 of 17. And once again, I'll use that property of exponents. I'll bring that exponent down in front as a multiplier, get x log base 10 of 5 equals log base 10 of 17. Solve for x by dividing, so we'll get x equals this fraction. Log of 17 divided by the log of 5. Now, my calculator, here's what I'm going to do. I'm just going to press the log key. I'll get a parentheses. I'll type in 17 and close it. Divide. Press that log key again. You get a parentheses and put in a 5. Close it. And my calculator is showing that x is equal to 1.76037. And according to the instructions, I'm supposed to round to 3 places. So there's 1, 2, 3. Now that number over here is below 5. So I'm just going to write this as x equals 1.760. Let's give this number 3 a try. So again, we've got an exponential function, right? Because the variable is in the exponent. So let's bring that down as a multiplier by taking the log of each side. So I'm going to take the old common log. So I'm going to get the log of 5 to the 5x minus 3. This will be the log of 25. Now here's the exponent. We'll bring that down as a multiplier, but I need parentheses to capture all of it. So it's going to be quantity 5x minus 3 times the log of 5. That's equal to the log of 25. Now, why don't we do this? I'm just going to divide by this. So here's what I'm going to get. I'm going to get 5x minus 3 is equal to the log of 25 divided by the log of 5. Now, I'm going to add the 3, so I'll get 5x is equal to, log of 25 divided by the log of 5 plus 3. Now I'm going to divide the whole thing by that 5, so let's divide by 5. So x is going to be, I have a big fraction here. I've got the log of 25 divided by the log of 5 plus 3 all over 5. So on my calculator, I'm going to have to type in this. Now this is all the numerator, so I'm going to collect that all in one parenthesis. So I'm going to type it like this. Let's put in a parentheses, and we will press the log key. All right, so I'm just going to press log. So you get, well, here's what you do. You press the log key, you get a parentheses, you put in 25. Press the divide key. Press the log key, you get a parentheses, now put in 5, close. Now, here's where I am so far. I've got the log of 25 divided by the log of 5. Now I want to add 3, so just out here, just add 3. Now that takes care of the entire top, so I'll close that off. Those have to match. And then I'll divide by, just type in a 5. And I got a 1 out of this. I'm getting now that x, I'll do it up here at the top right, I'm getting that x is equal to 1. Let's see what we can do with that. That is kind of surprising, but let's go back down here and see if we can do something with this. Or actually, maybe it can even go right here. Let's try that. Let's just try something. So this, I'll do it in this color here. So if you have the log of 25 divided by the log of 5, I can rewrite that as the log 25. I could write as 5 squared over log of 5. Bring that 2 down as a multiplier. We'll get 2 times the log of 5 over the log of 5. Those log of 5s cancel, and I just end up with a 2. Now, here's where I am. If I come back over here, what we just did is we simplified this one. I simplified that one, and I got 2. So now I've really got this equation here. I've got 5x minus 3 equals 2. Add the 3. We'll get 5x equals 5. Divide by 5. There's the 1. So now I'm convinced that x is equal to 1. Well, now we've got an exponential equation with base e. So the variable is t, so I'm going to have to use logarithms, but I'm going to use the natural log because that base is e. So I'm going to get this. The natural log of e to the t is equal to the natural log of 622. Now, the bases match here, right? This natural log, just kind of in your head, the natural log is really the log base e, and then of e to the t. And now these bases match, so I just get t. So what I started with, it's like, here's what we did. We started with a t, then we exponentiated it, and then we took the natural logarithm. We just undid what we did, right? So I started with t, I did something, then I undid it. So now I'm just back at t, right? So here's where we are. T is equal to the natural log of 662, And we can put that on our calculator. And I will write second. Okay, press the second key. Then press the log key. And right above the log key is ln. That's why we're pressing second. You get a parentheses and type in 662 and close. And when I do that, I am getting that t is equal to 6.49526, 6.49525, dot, dot, dot. But we are supposed to just round this to 3 decimal places. So 1, 2, 3, that number right there is below 5. So how about t equals 6.495. Let's go on to 5. Another exponential with base e, so I'm going to take natural logs of both sides. Now look, let's make this simple here. You know that if you have the natural log of e to some power, you just get x, right? You start with x, you exponentiate it, then you take the natural log, which undoes the exponential, and you write back at x. So I'm just going to write this original expression. Well, I'll take the natural log, but I know I'm taking the natural log. So how about if we just do this? I'll go down here. If I take the natural log, this is a step you could probably just skip. Negative 0.80t, that's equal to the natural log of 0.18. Now this right here I know is negative 0.80t. So I could just go from here, and write this. And this is equal to the natural log of 0.18. So why don't we just divide to get to t? T is equal to the natural log of 0.18 divided by negative 0.80. So on your calculator, you're going to press the second key. Then you're going to press the log key, because right above the log key is the ln key. You get a set of parentheses and type in 0.18, that's a 1/8, and divide by, okay, negative, I'm going to use parentheses, negative 0.8, and close it. And I am getting that t is equal to 2.4350. Oh, 2.14350. And if I round up to 1, 2, 3, that's a 5. So I'm going to round this up. So I'm going to say that t is equal to 2.144. Okay, now it's all approximate. It's really this. T is approximately 2.144. Let's solve this one. 21 to the x equals 7 to the x plus 1. Well, x is in the variable is in the exponent, so let's undo that exponential by using logarithms. Now, I'm just going to use a common log here. So I'm just going to take the log of both sides. So I'll get the log of 21 to the x is equal to the log of 7 to the x plus 1. Now I'm going to bring those exponents down in front as multipliers, so I'll get x log of 21 is equal to, now I've got more than one term, so capture all by using parentheses, x plus 1 times the log of 7. Now, I think what I'm going to do here is I'm going to multiply through here. I'm going to distribute. So I'm going to get x log of 21 is equal, now x times the log of 7. X log 7 plus, now here, I'll just get 1 times log 7, which is log 7. Now I've got x's on both sides. So I've got x on the left side, x on the right side. Why don't we get all the x's, say, on the left side? So let's subtract this one. So we'll get x log of 21 minus x log of 7. That's equal to the log of 7. Now over here on the left side, I can factor out an x. So I'm going to take that x out, and I'm left with this. Log of 21 minus log of 7. That's equal to the log of 7. Now, I've got a difference here, right? This is a difference. I could write this as the log, so let's do this. Let's say x times, if I have a difference, that comes from a quotient. The log of the first divided by the second. Okay, so the one single logarithm. The top is the first one, the bottom is the second one. And that's all equal to the log of 7. Now all I have to do is divide by that. So I'll do it up at the top. X is equal to this fraction, log of 7 divided by the log of 21 over 7. Now, I know what 21 over 7 is. It just happens to be 3. But I'm just going to keep it like this, because if it was 21 over 8, I couldn't do it. So here's what I'm going to type on my calculator. X is going to be equal to this. All right, I'm going to type in, press the log key, you get a parentheses, type in a 7 and close it. Divide it by, press the log key again, you get a parentheses, and I'm going to type 21 divided by 7 and close it. And I get that x is equal to 1.77 1243 1243 ... but round to 3 places. 1, 2. Now that is a 2 that's below 5, so I'll just truncate it. X equals 1.771. Now in 7 we've got a logarithmic equation. Now I see I've got a plus here. So I'm going to use that property of logarithms that says if I have the log of a product, that's the sum of the logs. So I'm just going to go backwards. Here's what I'm using. I'm using this property. If I have the log base b of, say, x times y, I get the log base b of x plus the log base b of y. Now, that's going that way. I can also go this way. So I'm going to have the log of the first times the second. So this is going to be the log, I'll use a bracket here. I'm going to have the first one times the second one, x minus 15, and that's all equal to 2. So I'm going to get the log of this quantity, x squared minus 15x, that's equal to 2. So I've got a log here. I want to eliminate that log, so I want to undo the effect of the logarithm, and I'll use the exponential function to do that. So I'm going to exponentiate each side by raising e to this power. Log base 10 of x squared minus 15x equals e to the 2. So just exponentiate both sides. Now on the left side, I started with the x squared minus 15x. I took the log, then I exponentiated it. Just brings me back to x squared minus 15x, and that's equal to e squared. Now how about x squared minus 15x minus e squared equals 0, and I'm going to use the quadratic formula. Now the quadratic formula takes a quadratic equation that looks like this: ax squared plus bx plus c equals 0. And all I need to know is a, b, and c. Now a is the coefficient of the quadratic term. Down here, our coefficient is just 1. So a is 1. b is the coefficient of the linear term. Now down here, our linear term is negative 15. And c, well, c is just a constant. So c, looking at the constant down here, is that negative e squared. So I'll write negative e squared. Let's substitute. So here's our quadratic formula. X equals this fraction, negative b plus or minus the square root of b squared minus 4ac over 2a. Substitute, we will get x equals, okay, the first up, negative b, the opposite of b. What is b? Negative 15, I want the opposite of that. Now I'm going to write everything. The opposite of b, the opposite of negative 15. plus or minus the square root of b squared, negative 15 squared, minus 4 times a, but a is a 1, times c, which is that negative e squared. Not to worry, our calculator will do that for us. All over 2 times a, 2 times 1. Let's simplify it up a bit. X is equal to, now here, the opposite of negative 15 is 15. So we'll get 15 plus or minus the square root of, okay, negative 15 squared. Negative 15 times negative 15 is 225. And then negative 4 times 1 is just negative 4. But negative 4 times negative e is going to be plus 4e squared. And all of this is over 2. All right, calculator time. So let's put in, I need that whole top to be divided. So I'm going to put in a parentheses. Then I'll put in 15. Now I'll do the plus one first. Plus, now I'm going to type in that square root. All right, so on my calculator, I have to go to the square root. And the square root is right above the x squared key. So I need to press second, and then way off to the left, I'll press the x squared key. All right. Now that actually gives me this, and that a square root, as I start typing, the square root bar on the top will expand. So what I'm going to put in here is the 225. All right, so type in 225, and then plus 4, all right, so plus 4. Now I need that e squared. So here's where I'm going to get e squared. On your calculator, if you press second, you have to press second, and then look at that LN key. All right, so press second. Look at the LN key. LN, off to the left, LN. Now, I get a set of parentheses. So press second, LN, and you see an E coming up here. I guess I don't get the parentheses. So no parentheses. I get E, and now I get an exponent up here. So you want that to be a 2. So type in a 2. I'll type in a 2, and then I'm going to arrow out of that. So arrow out of that. And then I'll type in, okay, I'm going to arrow again. I'm going to arrow twice to get out of that. And then type in a parentheses, and then divide by 2. Now when I did that, I am getting x equals 15.477409. Okay, now what we're supposed to do here is, what do they want us to round to? Okay, well, it doesn't say to round anything. It just says the solution is, okay, you know what? I'm going to round this to 3 decimal places like we were doing before. So I'm going to say that x is equal to 15.477. All right, now I still need the one for the minus. So in my calculator, what I'm going to do now is I'm going to change this plus sign, where is it, that plus sign, change that plus sign to a minus. All right, so just press second, entry. So I'm going to press second, top left, and then entry at the bottom right, or enter. All right, second enter, top left to bottom right. That brings back the last thing I put in, and arrow over to the plus sign. So put the arrow, use your left arrow, hit it on the plus sign, and change to a minus. Now the minus, just change it to a minus sign. So just type the minus sign and press enter again, and here's what I get. X is equal to negative 0.477. So I'm getting these two values for x. I'm getting 15.477 as well as negative 0.477. One more. Let's do number 8. Now I notice that I've got the sum of two logarithms, I can compact this into a product of the first and the second. So I'm going to simplify that left side by writing the log of, I'm going to use a bracket here, x times the quantity x plus 2, close. That's going to be the log of 63. Now let's eliminate the logs. Let's undo the effect of the logarithm by using exponentiation. So it's a common log. So I'm going to, in the last problem I think we used e. This time I'm going to use 10 because the base here is 10, right? The base is 10. So let's write 10 to the log of x plus 2, close. That's equal to 10 to the log of 63. Now, I just undid the log, so I just get those exponents. X times x plus 2 equals 63. We can solve this one. Just quadratic. X squared plus 2x equals 63. It's quadratic, so I'm going to set it equal to 0. X squared plus 2x minus 63 equals 0. Now, it's quadratic. First thing I'm going to try is factoring. Does that left side factor? X and x. 63. How about 9 and 7? 9 times 7 is 63, and they differ by 2. So I'm going to use a 9 and a 7. Now, the 63 is negative. So I'm going to put that middle plus sign with the bigger of these two products. The way I wrote it, the outer product is 7x. The inner product is bigger, so I'm going to put the plus sign here. So I'll have plus 9 minus 7. So now I'm going to get x equals negative 9 and 7. Now these are potential solutions. I have to check to make sure I'm not, I'm keeping everything defined. If I put in that negative 9, what do you get? Put that negative 9 in here. No, it doesn't work, right? Because it gets a log of a negative. So here's what I'm saying. If I tried to put that negative 9 in here, I would get the log of negative 9 plus the log of negative 9 plus 2. That would be the log of 63, I'm asking. Well, this is undefined. And so is this, because I get logs of negatives. The logarithm of a negative number does not exist. All right, so I can exclude that. So we need to exclude negative 9. Now that just leaves 7. So I could try this. Check. I'll say if x equals 7, then, all right, put that 7 back into the original. Put 7 back into the original, and I'll get this. The log of 7 plus the log of 7 plus 2, is that equal to the log of 63? Well, let's see. Let's simplify this. I'll get the log of 7 plus the log of 9. Is that equal to the log of 63? Well, this is the sum, right? That's the sum. I can turn that into a product of this times this. So I'm going to get the log of 7 times 9. Is that equal to the log of 63? And sure enough, 7 times 9 is 63, equal to the log of 63. It checks. So we're going to now conclude that x is equal to 7. Toss out that negative 9 and just conclude that we get to 7. That's it.